Hello everyone. In this video, I would like to tie up everything that we have been learning so far regarding the Haskell's type system. Um, so in this video, what we're going to do is we're going to do a couple of things. So first, let's just make sure that we please get a title down for today. So this is still going to be on Haskell, but we are looking more specifically on Haskell's type and type classes. All right. So now that we have at least some idea about what type classes are from our last video, what I'm going to do is first thing I'm going to do is I'm going to use the existing type class in Haskell, which is the EQ type class, and we saw in the last video that it has a couple of behaviors, and the behaviors within the EQ type class were defined as it has a method, the equal to method, and the signature for this method, or at least a type for this method, is I'm looking at two parameters that I would like to compare against for equality, and depending whether they are equal or not, I return back basically a Boolean value. And we also saw that these A's basically are type variables, and type variable meaning that these type variables basically hold a type, and one of the constraints on a type being, because we're currently looking at our type class, we're looking at a type class which is EQ. The constraint being that whatever the type variable is, at some point, is, if it happens to be an instance of my type class EQ, it has a certain obligations, it has a certain set of behaviors that it is expected to implement. Okay, so let's just get one more of these. I believe the other one was the not equal to. So the one was not equal to, which had the same signature. All right. Now, what I'm going to do is I'm going to create a class. I'm going to create a type here. I'm going to create my own type, and so what I'm going to say is somewhere in my Haskell, I'm going to say, all right, let's create a type. I'm going to give it a really silly name, and let's call this maybe Abbas Boolean. All right. So this is a type. The type is basically Abbas Boolean, and we're going to give it some possible values that it can actually hold. And so again, if you're already familiar, you may have noticed that this is what I'm really introducing here as an algebraic data type here. So all I'm going to say is again, I'm being a little bit silly here with my example, but I'm going to call this as it contains two possible values, which could be a C true. Okay, it could be a C true, or it could be a C false. All right. So again, as a quick recap, just so that we are all familiar, I've created a new type which is called Abbas Boolean, and all the possible values that can belong in this type are basically C true, and I'm calling C false. All right. Now, what I would like to do is I would like to somehow introduce this idea, this abstraction, that all values that are associated with this type, which is the Abbas Boolean, it should have the implementation to this equal to method and the not equal to method, meaning that if I have a value which is C true, so let's take let's just get some intuition first. So if I have a value, let's say, which is C true, which is, I'm just pulling the value from there. Okay, and if I perform on the C true, whether this value is actually equal to another C true, then the answer to this thing should actually be true. And another way to think about this is I can actually see the signature. I can see the signature from my equals method, and the equal method specifically outlines that I'm passing in some value of two values over here, value 1 and value 2, and as long as the type to these values are an instance of the equality, then I can basically use this equality method. But as of now, the way this type has been, it doesn't happen to be an instance. It doesn't happen to be an instance of my type class EQ. So this means that at some point I'm going to introduce in my code. I'm going to talk about how am I going to take my type that I've just created here, and how am I going to make this type and actually instance of my EQ type class. So in order to do that, we're going to look at a newer notion, which is the instance keyword. So I'm going to say at this point, let's say instance EQ, and in place of A, I'm going to put in there Abbas Boolean, and keep this in mind that because I'm currently in the type world, if this is the signature of my method, it means that whatever the type of this A, it must be a concrete data type, and I'm giving in the type that this is an Abbas Boolean, and each of these A's now get replaced with this new type Abbas Boolean, and I'm going to say that the implementation to this equal to is going to look like so this is my function, which takes in 2 parameters, and I'm going to say if the 2 values. So I'm just doing some pattern matching here, and I'm saying that if these values are basically C true and C true, then I'm going to return back a Boolean value, meaning in this case it's just going to be true. Likewise, if I have C false, and C false, then this is going to give back again a Boolean value true. Likewise, if I have a not equal to, sorry, let's just complete this off properly. Another value could be, I don't care what my input parameters are, but as long as it is not one of these true or false, and meaning it could be a true false or false true, then independent of what that is, it's always going to be a false. Okay, so this is one of the things I want to do today, is take this idea, put it in Haskell, and see if we can actually take this and do some example of this. So I'm just going to Alright, so what I'm going to do now is I'm going to just change gears a little bit, and I'm going to jump into Haskell. So let's do this. Let's create a module here. So I'm just going to let's just create a new module, and let's call this Haskell type. Okay, now I'm just going to call this Haskell type here, and first thing what I'm going to do in this is I'm going to define my new type, which is Abbas Boolean, which could take in a value of C true or C false. And then I'm going to say that this is going to be an instance. It's going to be an instance of my EQ class, and so this is going to be an instance of my CQ class, and let's perform the implementation to our equal to method. So I'm going to say that to my equal to method, as long as C true as my first parameter and C true as my second parameter, then the answer to this is always going to be true. Likewise, if I have a C false and the C false, the answer is going to be a true. All right. This is just, so what I'm doing here is, excuse me, I'm just providing my own implementation. I'm providing my own implementation as I see fit. As I see fit for my type Abbas Boolean. Yeah, I'm taking the behavior from the type class EQ that has the behavior for the equal to actually laid out as per its type, and I'm just obeying that type to provide my own implementation that corresponds to what are the values within a Abbas Boolean and when these values can be considered equal to each other. All right, and then finally, I don't care what these parameters are, the first and the second, and whatever they happen to be. In this case, a C true and a C false, or a C false and a C true, is always going to be a false here. So let's just save this. Let's just save this right now. Okay, and I'm just going to start my Haskell in the interactive mode here. And first thing I'm going to do is I want to make sure I'm actually in the correct directory where, so if I remember correctly, I need to change directory to my Haskell. Okay, and at this point I need to load my file, which was actually saved as Haskell type.hs. So I'm going to load Haskell type. All right, and of course I'm doing the load here. All right, so I got my module loaded, and let's just make sure everything is correctly done here at this point. So first thing, let's just say C true. Okay, let's just do let x equals to C true. All right, and let's run a type on x, and that already tells me that the type for x is basically a Abbas Boolean, and that makes sense because Abbas Boolean is my type here. The way I had done this, just to make sure that we are following along, let me quickly switch gears to my let's just quickly, there you go. So this is how I actually created my type Abbas Boolean, and Abbas Boolean can take in values which are C true and C false. So I just created a value in my Haskell saying let x equals to a value C true, pulling one of the values from here and assigning it to x, and then running a type on x, give back to me that this happens to be an Abbas Boolean. Okay, now given that, let's see if I can actually create one more y equals to, let's say, C true as well, and the type for this y should be Abbas Boolean. And now if I do x equal to y, I should get back a true here, because a C true and compared against a C true should give me a true. That's good. That's how I implemented the behavior in my Abbas Boolean. So again, let's just do this. Let's just run a type. So let's just run a type on. Let's just make sure this is correctly. Okay, there you go. So let's just run a type on my equal to method, and that's good. This is being pulled right from my type class, which is right here. Okay, so this is my type class. That's the formal definition of my type class, and now I have two values x and y. I have two values x and y, both belonging both belonging to my type that I've just created a pass boolean, and now I have a way to actually perform an equality between x and y, and get back a boolean value using the equality method. So if I run, I can see false. Whether this is equal to C true, well, they're both different values, and my implementation, if I've done correctly, should give me back a false. In this case, it should give me back a true, and so I hope this was useful. I hope this was useful. Just have some of the materials that we've been learning in the last video with a really simple example um, of creating a type and making the type an instance of my type class.